Show more. 3:46 p.m. I've been working on Nissan and Infiniti vehicles for 19 years. And in that time, I've watched perfectly good engines get destroyed by owners who were doing exactly what the sticker under their hood told them to do. Not because they were careless, because the information they were given was incomplete. And the information that would have actually protected their engine, the specific technical component level detail that Nissan's own domestic engineering team put to paper, never made it to them. Never made it to most mechanics either. Never got translated. Never got distributed. Just sat in an internal document that a handful of engineers in Alpama knew existed, while Nissans across America idled wrong, warmed up wrong, and wore out early because of it. In 2017, I was doing a technical exchange through a parts supplier I'd been working with for years. We visited a Nissan facility outside Yokohama. And while I was there, one of the senior technicians, a man who had been working on VQ and QR engines since before most American mechanics knew those engine codes existed, pulled out a printed document. 3 pages, dense, technical. He said, in the way someone says something when they assume it's common knowledge, "You train your customers on this, yes, for cold operation?" I told him we didn't have that document. He looked at me the way you look at someone when you realize a conversation is going to take longer than you expected. He sat down. And he started explaining, line by line, what Nissan's domestic engineering team had written about cold starts, cold idle behavior, and the first minutes of operation, and why none of it matched what American owners were doing to their cars. That conversation is why I'm making this video. If you drive a Nissan or Infiniti, a Maxima, an Altima, a Pathfinder, a G35, a 370Z, anything powered by a VQ, a QR, or a Mr. Engine, what I'm about to walk you through is the difference between an engine that gets to 250,000 miles in excellent internal condition and one that starts showing premature wear at 90,000. Hit subscribe before we go further. Because everything I cover from this point forward goes deeper than anything on the sticker. Here is what the mainstream approach to Nissan cold starts looks like in America. You get in the car, you start it. You let it idle for maybe 30 seconds if you're patient, maybe 10 if you're not. You pull out and drive. If it's winter, maybe you let it run a minute while you scrape the windshield. That's considered reasonable. That's what most people do. That's what the American owner's manual suggests with its vague guidance about allowing the engine to warm before aggressive driving. Here is what Nissan's domestic engineering team actually documented. The cold start sequence, the specific behavior of oil pressure, ring seal, fuel enrichment, and valve timing in the first minutes of operation, has parameters that do not match the American approach at any point. Not the idle duration, not the driveaway throttle behavior, not the RPM ceiling during the warm-up window, not the distance threshold before the engine reaches stable operating temperature. None of it. The gap exists because of how the document was created and for whom. Nissan's domestic engineering team in Japan writes technical guidance for the Japanese domestic market. That guidance is built around how Japanese engineers understand the specific failure modes of their specific engines. It is detailed. It is component-level specific. It references the exact tolerances that matter during cold operation and explains the exact ways those tolerances are violated by common driving behavior. The American market gets a translated version of the owner's manual, not the engineering document. The manual, which is a different thing entirely, written by a different team for a different purpose with a different level of technical specificity. The result is that American Nissan owners are operating their cars based on guidance that was written to avoid liability and cover basic operation, not to maximize engine longevity. And the people who pay for that gap are the owners at 80,000 miles, at 120,000 miles, when the timing chain starts rattling, when the oil consumption climbs, when the VQ starts feeling loose in a way it shouldn't yet. Let me walk you through what that 3-page document actually covered, what the Japanese domestic approach to cold starts actually looks like, and what you can do, starting today, to operate your Nissan the way the people who built it intended. Before I get into the specific items, I want you to understand the underlying principle that governed everything in that document. Because once you understand it, everything else makes sense immediately. The Nissan domestic engineering approach to cold starts is built around one idea: the engine is not a single object. It is an assembly of components, each of which has its own temperature curve, its own expansion rate, its own lubrication requirement, and its own specific vulnerability window. A cold start is not a moment. It is a process, and that process has a sequence. Rushing any step in the sequence forces a component to operate outside the tolerance it was designed for. Do that enough times, and the cumulative effect shows up inside your engine at an inspection you didn't expect. In America, we treat a started engine as a ready engine. In Japan, they treat a started engine as an engine that has just begun a process it needs to complete before it is asked to work. That one shift in framing is the entire document. Now the specifics. 1. The first 15 seconds are not idle time, they are pressurization time. In America, the common understanding of cold idle is that you're warming the engine up, letting it reach temperature. That's not wrong, but it's incomplete in a way that costs you. The first 15 seconds after a cold start are not primarily about temperature, they're about oil pressure reaching every oil passage in the engine. Here's what actually happens. When your Nissan has been sitting overnight for a few hours, even for 45 minutes in cold weather, oil drains back into the pan. The oil galleries that feed your cam journals, your lifters, your timing chain tensioner, your rod bearings, they are partially or fully drained. When you start the engine, the oil pump begins building pressure immediately. But pressure does not arrive at all components simultaneously. The oil pump builds from the bottom up, working outward through galleries that vary in diameter, distance, and elevation. For the VQ35DE and VQ35HR specifically, the engines in the Maxima, the 350Z, the G35, the Pathfinder, Nissan's engineering team documented that full oil pressure at the cam journals takes between 8 and 14 seconds from a cold start in temperatures below 60 degrees Fahrenheit. During that window, the camshaft lobes are operating against the cam bearings with reduced lubrication. The contact is metal on metal, or close enough to it that the wear mechanism is the same. What the Japanese domestic approach prescribes: after starting, allow the engine to idle without any throttle input, without putting it in gear, without turning on high-draw-electrical accessories for a minimum of 15 to 20 seconds. Not a minute, not 5 minutes. 15 to 20 seconds of true, undisturbed idle. This allows the oil pump to complete its pressurization cycle before any load is placed on the drivetrain. I've pulled valve covers on VQ35 engines with 180,000 miles on them. The ones that spent their life being started and immediately driven show cam lobe where you can feel with your fingernail. The ones maintained on something closer to the Japanese interval 15 to 20 seconds before any movement look like they were installed last year. Same engine, same oil type, same miles, different result. The pressurization window costs you nothing. It takes 15 seconds. And it is the single most important step in the entire cold start sequence because every other component on this list depends on oil arriving before load arrives. This is not in your American owner's manual. The manual tells you not to rev the engine when cold. It doesn't tell you why the first 15 seconds matter at the component level or what happens to your cam journals when you skip them. 2. The idle duration the engineers actually specified. After the pressurization window, the question becomes how long to idle before driving. The American standard vague guidance about warming up before aggressive driving gives you nothing specific. The Japanese domestic engineering document gave specific parameters based on ambient temperature and engine variant. Below 40 degrees Fahrenheit, 45 to 60 seconds of idle before movement. Between 40 and 60 degrees, 30 to 45 seconds. Above 60 degrees, 20 to 30 seconds is sufficient before low-load movement begins. These numbers are not arbitrary. They're tied to the thermal expansion behavior of the piston rings on the QR25DE and QR20DE, the engines in the Altima and Sentra. Cast iron rings expand at a different rate than the aluminum piston they sit in. When the engine is cold, the ring gap is slightly larger than designed operating spec. That gap means incomplete combustion seal. It means some combustion pressure bypasses the ring and enters the crankcase blowby, which dilutes your oil and adds to crankcase pressure. The idle period allows the aluminum to begin its expansion cycle, closing the gap toward operating tolerance. Drive hard during that window, high RPM, heavy throttle, significant load, and you're running a combustion process on components that are still moving toward their intended dimensional relationship. The wear rate during that window is measurably higher than at operating temperature. Nissan's domestic engineers documented this. They specified the idle window to minimize the time components spend under load before they reach acceptable dimensional tolerance. I have seen QR25 engines with documented severe cold start abuse. Owners who live in cold climates and drive hard immediately every morning show piston ring wear at 70,000 miles that I'd expect to see at 150,000. The compression numbers told the story before I pulled the engine. If you're in a cold climate and your Altima is already burning oil before 100,000 miles, this is the most likely cause, not a manufacturing defect. A cold start pattern. The idle time costs you nothing but 30 to 60 seconds. The repair it prevents is a full engine rebuild or a long block replacement. On a QR25, that's $3,500 to $5,000 at a shop. The math requires no analysis. 3. The throttle sealing during warm-up that nobody talks about. The Japanese domestic engineering document specified a throttle and RPM ceiling for the warm-up window, the period from initial movement to fully stable operating temperature. This is the item that will surprise most people because it isn't just about not flooring it when cold. It's about a specific upper limit that is lower than most drivers assume. For VQ series engines, the document specified a maximum of 3,000 RPM during the warm-up window, which the document defined as the period until coolant temperature gauge reaches the first stable position on the instrument cluster, not the midpoint. The first stable position, which on most US market Nissans occurs somewhere between 2 and 4 minutes of driving depending on ambient temperature. For QR series engines, the ceiling was 2,500 RPM during the same window. The reason is the timing chain tensioner. The VQ and QR engines use hydraulic timing chain tensioners. Hydraulic means oil pressure dependent. In a cold engine with oil that is still thick and passages that are still partially restricted by viscosity, the tensioner receives lower hydraulic pressure than it does at operating temperature. Under that condition, high RPM creates timing chain flutter. The chain oscillates slightly because the tensioner cannot respond quickly enough to rapid load changes. That flutter is the beginning of timing chain wear. It is not catastrophic in a single instance. It is cumulative. Every cold start high RPM event adds microscopic wear to the chain and guides. And when the timing chain on a VQ35 stretches enough to rattle, the repair is $1,200 to $2,500 depending on how far it progressed. The timing chain rattle on VQ35 engines is so common in America that there are forums dedicated to it, YouTube videos about it, entire aftermarket industries built around addressing it. In Japan, on domestic market Nissans maintained on the Japanese schedule, it is dramatically less common. Same engine, different approach to the first 3 minutes of every drive. Stay under 3,000 RPM until the temperature gauge stabilizes. On the highway, that means keeping it in a lower gear longer in the morning. In city driving, it means not jumping off the line at every green light for the first few minutes. It costs you nothing except the awareness that the window exists. 4. The warm-up drive pattern that protects the transmission. This one is connected to the engine warm-up, but the component it protects is different. The RAY5R05A and the JATCO CVT units, found in the Altima, Murano, Rogue, Pathfinder, and several Infiniti models, have their own cold operation characteristics that the Japanese engineering document addressed specifically. Automatic transmission fluid has a viscosity curve. When cold, it is significantly thicker than at operating temperature. Thicker fluid means slower hydraulic response in the valve body, which means slower clutch pack engagement, which means clutch packs experiencing slightly extended slip during engagement. Slip generates heat. Heat degrades the friction material on the clutch packs. Degraded friction material produces the fine particulate matter that circulates through the transmission and eventually clogs the valve body passages. The Japanese document specified that for the first 10 minutes of operation in temperatures below 50 degrees Fahrenheit, the CVT and traditional automatic units should be operated in a pattern that avoids sustained high load demand, meaning no extended highway acceleration, no sustained uphill grades at full throttle, and no towing. Light to moderate load, gradual acceleration, allowing the transmission fluid to reach its operational viscosity before demanding full clutch engagement capacity. JATCO CVT failures in America are expensive and common. Replacement runs $3,500 to $5,000 on most Nissan platforms. The number one contributing factor in my observation is transmission fluid that was never changed combined with cold start abuse that the average owner had no idea they were committing. The fluid change is straightforward, $150 to $200 every 40,000 miles using genuine Nissan CVT fluid, not universal CVT fluid, not a flush, a drain and refill. And the warm-up pattern protects what the fluid change preserves. I've seen JATCO CVTs with 280,000 miles in Japan. Smooth, responsive, no shudder, no slipping. I have seen them fail in America at 90,000. The maintenance and operational approach is the difference, not the unit itself. 5. The cold start oil pressure test you can do right now. Here's something the Japanese engineering document included that I've never seen in any American service documentation. A behavioral test for cold start oil pressure adequacy that requires no tools and no mechanical knowledge. When you cold start your VQ or QR engine, watch the oil pressure gauge if your car has one. If you have an Infiniti G35, G37, M35, or similar model with a full-gauge cluster, you have this. For models with only an oil pressure warning light, the test is modified. Watch the warning light. On a healthy VQ35 or VQ37 in good operating condition with fresh oil of the correct viscosity, oil pressure should rise to the normal operating range within 3 to 5 seconds of startup on a warm day and within 5 to 8 seconds in cold weather. If you're watching a light rather than a gauge, the light should extinguish within 2 to 3 seconds on a warm day, 4 to 6 seconds when cold. If your oil pressure gauge takes longer than 8 seconds to reach normal range on a cold morning, there are 3 possible causes the document listed. Oil viscosity that is too thick for the ambient temperature, meaning you may need a lighter winter viscosity. Oil level that is low, reducing the pump's available volume, or oil pump where that is reducing output pressure. Any of these conditions means your engine is spending the most vulnerable window of the cold start cycle with less lubrication than it needs. The document specified that Japanese domestic market owners should perform this observation monthly in cold months, not because something is wrong but as an early warning system. By the time your oil pressure light comes on and stays on, damage is either occurring or has occurred. By monitoring the pressurization time regularly, you catch the slow deterioration before it becomes a failure. Check your oil level every other fill-up. Use the viscosity your owner's manual specifies for your ambient temperature range, and watch that gauge on cold mornings. 3 seconds to normal pressure is healthy, 8 seconds is telling you something. If you found value in what I've covered so far, I want to point you to something specific. I put together a complete cold start and warm-up protocol for Nissan and Infiniti models, organized by engine family: VQ35, VQ37, QR25, QR20, Mr. 20, and the JATCO CVT. It includes the exact idle times by temperature, the RPM ceilings by engine variant, the oil viscosity recommendations by season, and the transmission warm-up protocol written out as a daily checklist. It's in the description, the kind of document that should have been in your glove box when you bought the car. 6. The fuel enrichment window and why you should never shut off a cold engine. During a cold start, your Nissan's ECU runs a fuel enrichment program. This is well known. What is less understood, and what the Japanese document addressed specifically, is the damage pattern created by starting a cold engine, running it for less than 2 minutes, and then shutting it off. Here's what happens. The ECU activates cold enrichment, delivering more fuel than a warm engine would need. This extra fuel during combustion partially ends up as raw hydrocarbons in the exhaust, and critically, as fuel vapor that enters the crankcase past the rings during the compression stroke. This fuel vapor dilutes the oil, a process called fuel dilution. A small amount of fuel dilution is normal and evaporates out of the oil as the engine reaches operating temperature. The elevated crankcase temperature drives the fuel vapor out through the PCV system. If you shut the engine off before it reaches operating temperature, before that evaporation process completes, the fuel stays in the oil. It reduces viscosity. It reduces the oil's film strength. And the next time you start the engine cold, you start with diluted oil from the last short run, plus the new enrichment cycle on top of it. For Nissans used primarily for short trips, under 5 minutes each way, this cumulative fuel dilution is the primary cause of accelerated bearing wear, sludge formation on the VQ's upper engine, and oil consumption that appears without any obvious leak. The oil is getting consumed through a mechanism the owner can't see and wouldn't think to attribute to their driving pattern. The Japanese domestic engineering document recommended that in situations where short trips are unavoidable, oil change intervals should be short to every 3,000 miles regardless of what the dashboard monitor recommends. The monitor calculates intervals based on driving behavior and conditions, but the algorithm was built around the assumption that drives are long enough to fully warm the engine. Short-trip Nissan owners need to intervene manually and shorten the interval. The oil change cost difference between 5,000-mile and 3,000-mile intervals on a VQ35. If you're using full synthetic in the correct viscosity, which is 5W30 for most US climate VQ applications, is roughly $200 to $300 per year in additional oil changes. The repair it prevents is early bearing wear, which progresses to rod knock, which at the VQ level means an engine that costs $4,000 to $7,000 to properly address. 7. The idle speed behavior that tells you the engine is cold starting correctly. The Japanese document included a section on what correct cold start idle behavior looks like from the driver's seat, not with diagnostic equipment, just from listening and observing. This is practical knowledge that most American owners have never been given. A healthy VQ35 or VQ37 on a cold morning should idle at elevated RPM, typically between 1,200 and 1,500 RPM, immediately after startup. This elevated idle is the ECU managing the cold enrichment, and the fast idle function designed to stabilize combustion while the engine is cold. It should remain elevated for approximately 90 seconds to 3 minutes depending on ambient temperature, then gradually step down to normal hot idle, 650 to 750 RPM, as coolant temperature rises. The step down should be gradual, not a sudden drop, not a surge and then a drop. If your Nissan cold starts to elevated idle and then drops abruptly within 30 seconds, the fast idle function is either malfunctioning or the coolant temperature sensor is reading higher than actual temperature, causing the ECU to exit enrichment early. Early enrichment exit means the engine is running lean, less fuel than ideal, while still cold. Running lean while cold is hard on the combustion chamber and the catalytic converter. If your Nissan drops to normal idle within 30 seconds of a cold start in winter temperatures, have the coolant temperature sensor checked. It is a $40 part and a 1-hour labor job. The lean cold start condition it prevents will eventually show up in your oxygen sensor readings, your fuel trim data, and ultimately in the life of your catalytic converter, which on a VQ platform runs $800 to $1,400 per side, and the VQ35 is a V6, so there are two. Watch your tachometer on a cold morning. Elevated idle for 90 seconds minimum, stepping down gradually. That is the correct behavior. That is what the engineers intended. 8. The coolant system's role in cold start protection. The Japanese document dedicated a full section to the coolant system not as a temperature management tool, which is how Americans typically think about it, but as a cold start protection mechanism. This distinction matters practically. The thermostat in your Nissan is not just preventing overheating. It is maintaining the temperature window in which the engine operates efficiently, which directly affects how quickly the engine exits the cold start vulnerability zone on every startup. A thermostat that opens too early, a common symptom of a partially failed or heat-fatigued thermostat, keeps coolant temperature lower than designed, which means the engine takes longer to exit cold operation, which means the cold start vulnerability window extends on every single drive. Nissan thermostats are designed to begin opening at approximately 180 to 190 degrees Fahrenheit and reach full open at around 200 to 210 degrees. A thermostat that opens at 160 degrees, which is where a fatigued one often ends up, keeps your engine operating below its design temperature range. The downstream effects are significant. Fuel economy drops because the ECU runs slightly richer at lower temperatures, oil takes longer to reach full operating viscosity and lubrication effectiveness, and the cold start vulnerability window extends by 1 to 2 minutes on every drive. The Japanese document specified coolant system inspection, including thermostat function verification and coolant condition, at every 30,000 miles, not just when the temperature gauge misbehaves. And it specified genuine Nissan long-life coolant, blue or green depending on the model year, at the correct 50-50 dilution. Not generic green antifreeze, not universal long life. The genuine fluid has the specific inhibitor package that protects aluminum components in the Nissan cooling system, which are extensive in the VQ architecture, from corrosion and pitting. A thermostat is $25 to $60 in parts, an hour of labor. That thermostat functioning correctly shortens the cold start vulnerability window on every drive for the life of the car. The coolant flush with genuine fluid is $80 to $120 every 30,000 miles. The failure it prevents is a warped aluminum head from repeated temperature swings, which on a VQ35 is a $2,000 to $3,500 repair depending on severity. 9. The variable valve timing system's specific cold start vulnerability. The VQ35HR, VQ37VHR, and several QR series engines use Nissan's VVEL or CVTC variable valve timing systems. These systems are oil pressure dependent. They use solenoids controlled by the ECU to vary cam timing based on operating conditions, advancing or retarding the camshaft to optimize power, fuel economy, and emissions across the RPM range. On a cold start, These systems are operating on the same compromised oil pressure that the rest of the engine is working with in the first 15 to 30 seconds. But the variable valve timing solenoids have a specific additional vulnerability. Their passages are small enough that the thick cold oil, before it is warmed to operational viscosity, flows through them slowly. The ECU, not knowing the fluid is thick, commands the solenoid to actuate the cam phaser. The phaser moves slowly. The cam timing changes more gradually than commanded. In mild cases, this causes the rough cold start behavior that many Nissan owners dismiss as normal, the slight lope or hesitation in the first 30 seconds. In repeated severe cases, cold weather, immediate high RPM, immediate high load, the phaser vanes experience wear from the combination of high demand and low hydraulic response speed. The repair for a worn VQ37 cam phaser is $800 to $1,200 per bank. The VQ37 is a V6, there are 2 banks. The prevention is the oil viscosity specification. In cold climates, anywhere that sees temperatures below 30 degrees Fahrenheit regularly, the Japanese engineering document specified 0W30 full synthetic over the 5W30 that appears in most American documentation. The 0W designation describes the oil's cold flow behavior, and 0W flows to the VVT passages measurably faster than 5W at startup in cold temperatures. Full synthetic is non-negotiable for these systems. Conventional oil's cold flow behavior is not sufficient for the VVT passage diameters in the VQ architecture. If you drive a VQ35HR or VQ37VHR in a cold climate, 0W30 or 0W20 full synthetic, check your specific model, is not a luxury. It is a mechanical requirement that your American documentation didn't make clearly enough. 10. The documentation gap for the Mr. Engine family. This one matters if you drive a Nissan Juke, a first or second generation Nissan Rogue with the 2.5, or an Infiniti QX30 vehicles running the Mr. 16 DDT or Mr. 20DE. These engines have a cold start characteristic that Japanese domestic documentation flagged explicitly and American documentation addressed not at all. The Mr. Series turbocharged engines, specifically the Mr. 16 DDT, run the turbocharger on the same oil supply as the engine. The turbocharger bearing, which spins at up to 150,000 RPM under boost, requires continuous oil flow for lubrication. On a cold start, the turbocharger is receiving the same delayed, viscosity-impaired oil supply as the rest of the engine. The turbo bearing's clearances are tight. Tight clearances plus thick cold oil equals a bearing that is operating on a thin film rather than a full film of lubrication. The Japanese document specified, for Mr. 16 DDT applications, do not apply boost, meaning do not accelerate hard enough to spool the turbocharger until coolant temperature reaches the first stable gauge position. That is typically 2 to 3 minutes of gentle driving in moderate temperatures, longer in cold weather. In America, Juke owners drive their cars the way the advertising suggested: spirited, fun, punchy off the line. In cold weather on a fresh start, the Mr. 16 DDT turbo bearing is the part that pays for those first few minutes. When the turbo bearing fails, oil gets into the intake tract, you see blue smoke, and you're looking at a turbocharger replacement of $1,200 to $2,000 installed. In Japan, Mr. 16 DDT engines in the Nissan Note and Juke equivalents regularly reach 200,000 kilometers without turbo issues. Operators there understood the warm-up requirement, not because the manual told them, because the engineering guidance made it into the operational culture in a way it never did in America. No boost until the gauge stabilizes, 2 to 3 minutes. If you own a Juke or an Mr. Series Nissan with a turbo, this is the single most protective change you can make to your morning routine. So as you leave here, commit to one thing. Pick one of these 15 points and implement it this week. Not all of them at once, just one. Maybe it's the 90-second idle rule. Maybe it's waiting 5 minutes before turning on the heated seats. Maybe it's checking your oil every third fill-up. Pick one and make it automatic. The next week, add another. In a month, you'll have the entire protocol running on autopilot. In a year, your oil analysis will show the difference. In 5 years, your engine will show it. And at 250,000 miles, when your friends are rebuilding theirs, you'll still be driving yours. Thanks for watching. Subscribe so you don't miss the oil analysis comparison next week, where we put numbers to everything we just discussed. I'll see you then.